Hey, hey from West Virginia. Someday. But today is the day for Joke of the Day because I know it's your favorite part of the day. Okay, so how do you find Will Smith in the snow? You know the actor Will Smith? How do you find Will Smith in the snow? Well, you'll look for the Fresh Prince. Fresh Prince. And then Fresh... Okay, anyways. What we are going to look for is writing equations for parallel and perpendicular lines. Now, let's review first what we know about parallel lines. We definitely know that they never intersect, and because they never intersect, that means they have to tilt the same way, and that, I can't make these tilt, but anyways, they have to tilt the same way, and that tilt is the slope of the line. So it makes sense that parallel lines are going to have the same slope. Now let's talk about perpendicular lines. What do we know about those? Perpendicular lines, they intersect at 90-degree angles. And because of that, because of this 90-degree concept that we see right here, that means if one is going to be, I'm working backwards here, if one's puff puff positive and the other one's nice negative, we are going to have opposite signs on those slopes. In addition, in order to get one to the next one, we're going to have to flip it like this. And you can see that that flipping concept is the concept of reciprocal slopes. So perpendicular lines are going to have opposite reciprocal slopes. That information allows us to take one line whose equation we know and create another line that is either parallel or perpendicular to it and be able to write that line's equation given that we know one of the points that that line goes through. And we're going to do a couple of examples of that. So in each of our examples, we're going to be given some information such as the point that the second line goes through and whether that second line is parallel or perpendicular to the first line, and we're going to be given the equation of the first line in both of these examples. So we're going to take that given condition, we're going to write the equation for that second line using point slope form, and then once we've got that equation of the line, then we're just going to do this idea of transforming and translating the equation. And we're going to translate it into the slope-intercept form and then translate it once again into that general form. So let's take a look at this first example, and it says that we have a line, a second line, a new line, and it passes through the point 4, -7. We know that this second new line is perpendicular to the line whose equation is x minus 2y equals 3. Now remember, the equation of the line is the name of the line, but we can use that equation to figure out where that line sits. So we have this initial line here. We're creating a second line. That second line is going to be perpendicular to this line right here, and that second line is going to go through this point that we see right here. Second line is going to go through that line, through that point, perpendicular to this line here. Now, perpendicular, what do we know about perpendicular lines? Oh yeah, they have opposite reciprocal slopes. So therefore, if we knew the slope of the original line, we could get the slope of the second line because all we would have to do is flip it and change its sign. Well, can we get the slope of this original line? Certainly, because all we have to do is rearrange this, put it into slope-intercept form, and when it's in slope-intercept form, the slope is going to sit right in front of that x. So now we need to recall, what does slope-intercept form look like? Let me get a different color up here. Slope-intercept, remember, it looks like y equals mx plus b. And once I've got it in that form, my slope is sitting right here in front of that x. But how do I know that this is in that form? Yes, right here. When that y is by itself, then this is in that form, and the number sitting in front of the x is going to be my slope. So I'm going to take this, I'm going to rearrange it to get that y by itself. In order to do that, I need to slide that x out of the way, which means I'm going to subtract it. And when I do, that leaves me with a -2y equals -x plus 3. Remember, sign in front's a sign that goes. When you go to a meeting, you don't put your name tag on the back because I have no idea who you are. You put that name tag on the front so I can identify your face with your name. The sign in front is the sign that goes. So this negative is the name tag for the 2y, and it stays with it. When I slide the x over, I'm subtracting, so it becomes negative. This is positive. I'm so close to getting that y by itself. All I have to do at this point is divide every single term by a -2. That will give me y equals 1/2 x minus 3/2. Now that minus 3/2, I'm not terribly concerned about it. It's right here that I want. The slope of this particular line right here, its slope is going to be 1/2. And I can use that slope in order to figure out the slope of the new line. Because remember, perpendicular lines, opposite reciprocal slopes. So my second line here that goes through this one and is perpendicular, they're going to have opposite signs. This one's positive, so the new slope is going to be negative. And I'm going to flip that, and when I flip it, I get a -2. So here is the slope of that new line. Now, the new line, I know that it has this slope and goes through that point. Well, if I'm given a point and a slope, and mathematicians are not creative at all. We call it like we see it. So if you're given a point and a slope, what form of the equation of the line do you use? Oh, yes, you use your point-slope form. Now, let's recall what point-slope form looks like. And let me get a different color up here so it doesn't mix up. Point-slope, what does that look like? Y minus y1 equals m times x minus x1. And remember, this x and this y, they have subscripts on them. The numbers below, these are not exponents, they're subscripts, and it means first x, first y. In other words, this is the x and the y that go with the point that's going to be on the line. This does not have a subscript, this does not have a subscript. To remind me, they stay as variables. That's why they don't have subscripts on them. So when I take this point and this slope and I plug them into that point-slope form, now I'm going to have y minus y1 is this point right here, -7, equals m, which I just figured out to be a -2, times x minus the x-coordinate right here. Now, when you're in point-slope form, we do things that I call cleanup. In other words, you know subtracting a negative is really adding a positive. So you know what you really have is y plus 7 equals -2 times x minus 4. Actually, let me slide this over just a little bit. There we go. Y plus 7 equals -2 times x minus 4. And in point-slope form, we retain the parentheses. We don't need to distribute that -2 through the parentheses. We only have to do what I call cleanup. Cleanup is things like subtract a negative. I know that that's really adding a positive. So ta-da, here I have point-slope form. So now, remember, the directions had 3 parts to them. And here is the first part, point-slope. Now, the next 2 parts are, let's take this, let's translate it into slope-intercept form. Remember, slope-intercept looks like this. That has the y by itself, so I need to slide this 7 over, and also notice there's no parentheses here. So what I'm going to have to do to transform this into that slope-intercept form is I'm going to have to slide the 7 over, distribute the -2 through in order to get rid of that parentheses. And it does not matter which order you do that. You can either slide the negative or distribute that -2 through first, then slide the -7, or you can slide the -7, distribute through. Makes no difference the order that you do it. Now me, I have a tendency that I try to go ahead and distribute first and then slide this over, simply because if I go ahead and slide this over, a lot of people have a very bad habit of distributing that -2 through. They kind of get a little bit excited about distributing finally, and they distribute all the way back to that -7. So to prevent that mistake from happening, I make a habit of going ahead and distributing through first. -2 times x is a -2x, -2 times -4 is a +8, and then what I do is slide that -7 over. So at this point, I'm going to subtract that 7 here, subtract that 7 here, and when I do, I'm going to get y equals -2x plus 1, and there we go. That is going to be my slope-intercept form. And so that is the second of the 3-part directions. And then the last part says, let's put this in general form. Okay, now we got to recall what general form looks like. And remember, general form says, let's put everything on one side, the x, the y, and that constant. Let's set the whole thing equal to 0. And we have no fractions and decimals, and that front coefficient's positive. Well, notice we don't have fractions and decimals here anyways. Sweet. There's 3 criteria to be in general form. 1 of them is done. So I need to get my x and my y together and make sure that the coefficient of the x is positive. So therefore, probably the easiest thing to do would be to slide this over here, because when I add that 2x to the other side, I will get a 2x plus y. That puts the x and the y together. The front coefficient's positive. Let's slide that 1 as well, and that will get everything over there. Ta-da! We have general form right there. So the third of our directions is done. We have taken our first equation, we have figured out its slope. Because we know that the 2 lines are perpendicular, we took it, we flipped it and changed its sign. We used that new slope in this point to put it into point slope form to write the equation of the second line. So here's the equation of the first line, here's the equation of the second line. This is in point slope format. Now we're just rearranging these terms in order to put it into new formats. So the first of the new formats is put it in slope-intercept where the y is by itself, which we did here. And then this third format is to put in general form, slide everything over there to one side, get it set equal to 0, make sure your x is positive. Now, let's try another example of that, just because I want us to feel really confident in this. We're going to have the very same directions that say, okay, I've got the equation of one line. I know that that line is going to be parallel to another line, and I know that that other line that's parallel to it goes through this point right here. So the directions say it's going to pass through this point, it's parallel to the line whose equation is this. So here is my first line, and I know that the second line's parallel to that. Well, what do you know about parallel lines? Yes, they have same slope. So if I could get the slope of this line, then I would say, okay, the new line has the same slope because parallel lines have same slope. How am I going to get the slope of this line? Yes, I'm going to put it in slope-intercept form, which means I'm going to get the y by itself. When I do, the number in front of the x is going to be the slope. So let's get this y by itself, and what we're going to do is first we're going to subtract off that 5x, and then what we're going to do is subtract off the 12. And now we are dangerously close. All we have to do is divide by 2 on every single term. Now, negative divided by positive is negative. 5 halves does not simplify. Negative 12 divided by 2 gives me a negative 6. That's not the important part. Right here is. So the slope of that first line is going to be a negative 5 halves. Now what I'm going to do is take that slope and I'm going to use it in my second line. And remember, those 2 lines are parallel. So what do I know then about the new slope? Yes, that new slope is also going to be negative 5 halves. So the new line has a slope of negative 5 halves and goes through this point. When I'm given a point and a slope, what form do I use? Yeah, point slope form. Mathematicians are not creative. We call it like we see it. So if I'm given a point and a slope, I'm going to put it into point slope form. Well, point slope, remember, is y minus y1 equals m times x minus x1. And remember, this y stays as a variable because it has no subscript on it. This x stays as a variable because it has no subscript on it. So these have numbers to remind me, aha, the numbers go in these. So this becomes a 0, and this becomes a negative 6. And my slope, well, I just figured it out, it's negative 5 halves. Now, subtracting a negative is really adding a positive. So here's that cleanup that I've been talking about, that this becomes a negative 5 halves times x plus 6. And the other cleanup that I can do is, you know, the y, when you're subtracting 0, you're not doing anything. So this is just a y. So here we have the equation in point slope form. Now remember, there were 3 parts to these directions. The first was, write the equation. We did it. The second was, now let's transform this. So we're going to transform it first into slope-intercept form. And remember, slope-intercept form is your y equals mx plus b. And remember, you know that you're in slope-intercept when this y is by itself. So I need to take this, oh, the y is by itself. So I think I'm done. However, notice the other thing that's not here that is here. Yes, there's a parentheses. So the only thing I need to do to get it into slope-intercept form is to distribute this through. And when I do, I will get y equals negative 5/2 x. Now put that 6 over 1, and remember, multiplying those fractions, you are still in my math gang. We are going to multiply those fractions. We're going to cancel on those diagonals. We're going to cancel up and down, and then we're going to shoot straight across. So when I check these diagonals right here, 2 goes into 2 once, 2 goes into 6 3 times. Nothing cancels on this diagonal, but here I get a 5 over 1, here a 3 over 1, so nothing cancels up and down. I'm ready to shoot straight across. So across, negative 5 times 3 is a negative 15. And on that denominator, 1 times 1 is 1. All right, there it is. The y is by itself. This, my friends, is slope-intercept. So now all I have to do is transform it into general form. So with general form, what we have to do is we have to get everything on one side set equal to 0, make sure that the x coefficient's positive, and get rid of all the fractions and decimals. And it does not matter the order you do this. Makes no difference whatsoever. Just get all three things done. So lots of people like to go ahead and get rid of the fractions. So I'm going to do that first. And what's making this a fraction is that denominator of 2. So you know that in order to get rid of that denominator, what I'm going to do is multiply by it. Now remember, I'm multiplying the entire equation by 2 because this is a pan balance. I want to keep it balanced. So what I multiply here by 2, I'm going to have to multiply on both sides, meaning every single term gets multiplied by 2. Here, once again, in that gang, we're going to cancel those diagonals, and I get a negative 5x minus 30. And now all I have to do is slide everything to one side, making sure the x is positive. Well, since this x is negative, I think the easiest thing to do would be to slide these over here because that will make it positive. Because I could slide this 2y over. Matter of fact, let me do that because I want to illustrate something. If I go ahead and slide that 2y over, I get a negative 5x minus 2y minus 30. And the only problem with this is that this is a negative. It really isn't a problem that the 0 is over here. A lot of people think in that general form, all of this needs to be over here and the 0 needs to be on this side. That's not true. I just need to have everything on one side and a 0 on the other side. That's general form. It doesn't matter which side it's on. So this is okay. The problem is having this negative here. But you know that in order to fix that, you can either divide every single term by a negative, you can multiply everything by a negative. The bottom line is, regardless whether you divide everything by a negative or multiply everything by a negative, you're just changing all the signs. So I'm going to change this sign, I'm going to change this sign, and I'm going to change this sign. Ta-da! We have general form. It's as easy as that. So hopefully you're seeing that. You plug into this, and then you are just rearranging terms in order to translate it into those other forms. So, biggest thing to understand about these types of situations is parallel lines, like we said before, they have same slope. Perpendicular lines have opposite reciprocal slopes. So if you're told to write the equation of a line that is parallel to another line, you better ensure that you keep the slopes the same once you figure out the slope of the first line. If you are told that you have perpendicular lines, then you're going to need to take the slope of the first one after you have rearranged it to get the slope, take that, flip it, and change its sign, and then like I keep saying, mathematicians are not creative. If you're given a point and a slope, in this case we were given a point and a slope, you're going to plug that into your point-slope form, and remember, there are subscripts on these to remind me numbers go here, slope goes here. And then after that, it's just a matter of rearranging and transforming and translating. And your slope-intercept has the y by itself. General form says get everything on one side, make sure your x is positive, and get rid of all those fractions. I hope that helps. Have a great day.